Okay, Assalamu alaikum. Uh, in the last lecture, we talked about functions. We were talking about functions. In fact, we have been talking about functions for quite some time now. In the last lecture, precisely what we talked about related to functions, our discussion focused mainly on the different ways in which we can pass arguments or inputs to functions. So we said that you can pass arguments or inputs to functions either by value, like you can call functions by value, you can give them input, or you can pass arguments to functions by value, or you can do it by reference. Okay, so we differentiated between the two, the value and the reference. We did that. Here in this lecture, we'll continue our discussion of call by value and call by reference, and here we will elaborate. I guess we elaborated that in code as well, like what do we mean by a reference. So we said that reference is basically an alias or another name for a variable. So when you create a reference to a variable, that reference is just like another name for the variable. You do not When you create a reference, that does not result in the creation of a new variable or in the allocation of new space to a variable. Rather, what it does is it only results in the creation of a new name for existing variable. So you just get a new name, an extra name. So you get two names for the same location in RAM. You can refer to the same location in RAM using two different names. That is what the effect of reference is. So references are important. At times we may need to pass arguments or inputs to functions through references. And that is specifically true in the case of arrays when we will be talking about arrays. So that is very true in the case of arrays. In this lecture, we'll talk about const references. We have talked about const variables or constants. So we will create const references, and you will see what is the benefit of const references. So we'll talk about that as well, and we'll also talk about namespaces and using declarations. So we have been using namespaces, but in the very beginning, in our very initial lectures, we said that we'll only we won't talk about namespaces. We'll just copy this part of the code and we'll use namespaces as it is. So here we'll briefly talk about namespaces, like why do we need namespaces? What is the purpose of namespaces? I guess we talked about that a little before as well, but here we'll do that with an example. So let's get started. So we talked about passing arguments to function by references, and we demonstrated that. We'll demonstrate here in this lecture again as well. And we said that you can pass arguments or inputs to a function by reference, but you should always avoid that. Like you should avoid non-const references as arguments to functions. Okay, why? There's a reason for that. The reason is that if you pass an argument by reference and that reference is non-const reference means you can change uh, that reference. So let's first create a project side by side, and I'll copy this code there, and then we'll talk about this as well. So let us go and create a project. Let's create a console application, and this console, this is computer programming. Let us give it the title. This is function and references. So we are talking about function and references. Okay, so I hope you remember what references are. Okay, so let's say we have this variable int a, and let's say a has the initial value 10, and let us create a reference variable int. This is how you create a reference variable. Now b is a variable, uh, and it is a reference type. It is not a value type. By reference type we mean what we mean is that it can store references or addresses of other variables. It cannot store a value. Okay, so we are declaring b as a reference to a variable of type integer. So b can store like b, you can initialize b to not to some value. You cannot say int reference b is equal to 25. This is wrong. Like, you cannot do something like that. If you try to compile it, the compiler should flag an error here. Okay, so you cannot assign 25 value to a reference type. It is not a value type. This is a value type. This variable is supposed to store values. That's why we can assign it the value 10. This is supposed to store an address of another integer variable, so we cannot assign it a constant value. So you have to assign it some existing variable a, so we are assigning it a. Okay, so now this is fine. This won't result in any problem. Okay, this is fine. Now when you do it, we have seen in the previous lecture, when you say when you declare a reference type, and you initialize it with another variable. So now in RAM we have one physical variable, we have one integer variable, and here in your program you have two different names to refer to that variable. Okay, so if you say cout a is equal to, okay, a is equal to a, so you'll get the value a is equal to 10. That will be printed on the screen. And if you say cout b is equal to b, okay, so b is equal to 10 will be printed on the screen. Now if you do something like this, if you say b is equal to 20, and then you uh, output, you like execute these two statements, so then a is equal to 20 and b is equal to 20 would be printed. Okay, so we are changing b here. We are saying b is equal to 20, but once this statement is executed, so the output of this statement, a is equal to, it will also be 20 and b will definitely be equal to 20. So why would a equal to, yeah, why would the value of a be 20? It is because we have created b, we have declared b here as a reference type. So b acts like an alias or urf for a. It is another name for a. Okay, so we only have just one physical variable in RAM, and it has these two different names. So whether you say a is equal to something or b is equal to something, you're basically referring to the same variable. Okay, that is what it means. So if you compile this file, it will compile fine. You can build and run it, and you can see the output. So initially a is equal to 10 and b is equal to 10. That would be the output. A is equal to 10 and b is equal to 10. Okay, and then we changed b, and we said b is equal to 20. We assigned the value of 20 to b. So when you print a, so a is also now 20. Okay, and b is definitely 20. So why is a 20? Because a and b are the same physically. It is just one location, one piece of 4 bytes memory, and it has two different names, a and b. So when you say a is equal to something or b is equal to something, so you're basically referring to the same place in memory. Okay, that is what it means. Now let us declare this thing as const. Let us create a const reference. So how do you declare something const? Use the keyword const. So const int p is equal to something. When you declare something to be constant, you have to initialize it at the time of declaration. Okay, that is true about value types as well as reference types. So say for example we want to create a constant variable. So let us say const float pi. So we want to create a variable pi with some constant value. Okay, say 3.1415 something. Okay, so now we want pi to be a constant variable. It is of type float and we want it to be constant. So you have to use the keyword const then. Why do you want it to be constant? Because the value of pi does not change. So you want to make sure that nobody even accidentally changes the value of pi. So that's why you declare it with the keyword const. Okay, that's why you declare it with the keyword const. So this is a value type. If you want to declare a constant value type, you have to use the keyword const, and you have to initialize the variable here. If you don't initialize, this is an error. Okay, so this is an error. You cannot uh, declare a constant variable and not initialize it. This is an error. Okay, so I hope you're aware of this. So you have to declare it, you have to initialize it at the time of declaration. So just like const value types, like this one pi here, when you declare it, you have to initialize it at the time of declaration. The same is the case with a const reference. If you have a const reference, as soon as you declare it, you have to initialize it. Like you cannot delay the initialization of a reference to some later stage, okay? So it has to be initialized here at the very beginning, the const reference. And the other thing, let me comment this line out first. Let us see. So you have, like, this code won't have any problems, okay? Now, okay, so this is a const reference. It has to be initialized at the time of declaration. Let's look at it again. Uh, so yes, be declared as reference but not initialized. So whether it is a const or non-const reference, it has to be initialized. So let us initialize it. Okay, it has been initialized. So now B is a const reference and it has been initialized with A. So B refers to A as well. There is just one variable A, and that variable can be referred to by two names, A and B. Now we have declared B as const. Can we do it? Can we do something like this? Can we change B? So if you declare B to be a const reference, then you cannot change B at any stage in your program. Just like pi, if you declared pi as a const variable, so you cannot change pi. Okay, so let us look at this code. Okay, we have done that. So in the case of value types, we have declared constant variables, and then we have tried to change those constant variables later on, and we couldn't. The compiler flags an error because you declare a variable as const and then you cannot change it later on. So similarly, B has been declared as a const reference. So here you cannot say B is equal to 20. Okay, you cannot say that. So you will get an error here. Assignment of read-only reference B. So B is a read-only reference. You cannot assign it any value. You can definitely say A is equal to 20, and that will change both A and B. You can say A is equal to 20 and it will change A is equal to 20 and B is equal to 20. You'll get that message, okay? But you cannot change the variable A through the reference B. You cannot change the variable A through the reference B. Why? Because the reference B has been declared as constant. You can change A directly. You can change A directly. Before that, when B was not declared as constant, like we could change that variable both using the handle A and handle B. Okay, so we could change it using either of its names. It was a single variable, and we could refer it to that variable using two different names. It had two different names, A and B. So you could change that variable using either the name A or B. But when you declare B as a constant, then you cannot change that variable using the reference B. You can change it using A. That you can do. You can compile it. This is fine. You can build and run. So here you see, like, A is equal to 10, B is equal to 10. This is the output of these lines, statements at lines 10 and 11. Then we change A, and that changes B as well. Okay, that changes B as well. Why? Because B is a different name for A. B is a different name for A. B is a reference and it has been initialized with A, so B is just a different name for A. So you can change the variable A through the name A, but you cannot change it through the name B. Why? Because we have declared it as a constant reference. If it were not constant, then you could change that. That is what we did before. So I hope, like, you know the difference between a reference and a const reference. This is a reference. Okay? This is just B is a reference. So B is just another name for A. You can use B exactly the same way as A. If you change B, A would change. Okay? So when you have just B as a non-const reference, so you can do something like this. You can say B is equal to 20, and it will be fine. You can build and run this code and this is fine. Okay. But when you declare b to be const reference, then you cannot say something like this. Now b is const, you cannot change it. Okay. You can always do this thing. A is not const. A has not been declared constant. So you can always change A directly. And that would change B as well. Because B is just a different name for A. Okay. So here you can see A is equal to 20, B is equal to 20. This is fine. Now what is the benefit of, what is the utility of const references? So the utility of const references comes in functions. Okay. So you should always, when you're passing arguments by reference, you should always use const references. You should avoid non-const references. Why should you avoid non-const references? So here look at these two functions. Let us write these two functions, increment1 and increment2. Okay. So let us write these functions. One is int increment1. Okay. So we pass it some value, some integer value, say int x, and it returns incremented value. This is just a very simple naive dummy kind of function. Okay, and then let's have another function increment2, and increment2 would return also gets some value, and it also returns incremented value, or it increments it. And this value, it does not, since it returns void increment2, the function increment2 returns a void value. That means it does not return any value. Void is nothing. It won't have any return statement. So how would it increment x? So that means x has to be passed by reference. X has to be passed by reference so that increment2 can change x. Increment2 can change x. Okay? And increment1, it will just it gets x by value, and it will return the incremented value of x. How would it do it? So let us define these functions. So here we define these functions. The first one is increment1. So what we do is we return x plus 1. Okay, so we return x plus 1. So this is a function. It returns an integer value. Which integer value does it return? If you give it x, it will return x plus 1. That is what it does. It increments the value of the argument by 1 and returns that value. Now here, this is another function, increment. This is a subroutine, to be very precise. It does not return any value. Void means it returns nothing. It will not have a return statement. Okay. So if it does not return a value, how would it increment x? So it would increment x. Since x is passed to it by reference, so it can directly say increment x. Okay? So x would be changed. X would be changed or incremented. Now, if you have to write a function like this which increments the value of its argument, you should write it this way. You should not write it this way. These are two different ways of doing the same thing. This is recommended. This is okay. This is not recommended. Okay, this is not okay. Why? Because you are giving this function increment2 the ability to change x. Okay, increment 1 can also change x, but that change is local. That change is local. It only affects this x, which is a local variable to the function increment 1. It will not change the variable in the main function. Okay, so what do we mean by that? This is what we mean by that. Say for example, I call the function increment 2 here. Okay, sorry, increment 1 here. So we call the function increment 1 here, increment 1, and we pass it the value a, value of the variable a. Okay, so increment 1 function will do whatever it has to do. What will it do? When the C++ like compiler comes across this statement, so it will jump to increment 1, this function, A will be copied into the variable X. So A would be a different variable, X would be a different variable. Okay? And then this function is returning X plus 1. So X would be added 1 to it, and that value would be returned here. We are not doing anything with that value here. So you won't see anything going on the screen. Nothing will happen there. If you print A and B, you will get 10. Okay? Let us get rid of this statement. Now here, let me call increment 2, and let us give the value A, pass the value A to increment 2. Okay? Now what will happen? What will happen is increment 2 would be called, and here you are passing A by reference. That means the address of A would be passed to X. So X would be just another name for A, and you are pre-incrementing X. So you are changing X. Since X is a reference, that means X is just another name for A. So basically you're changing A. A is a variable in the main function. So increment 2, this function is changing a variable in the main function. It is changing a variable in the main function. Okay, so that is something that you shouldn't be doing. This is the kind of access that you should not be granting any function. No function, ideally, no function should have uh, an access to the main function, to the variable in the main inside the main function. It should not be able to change any variable inside the main function. That is what it does right now. Okay, so let's see if that is the case or not. We compile it, it compiles fine, and then let us build and run it, and then let's explain the output. So here, let me come here. So here first A, like we know A has been initialized to the value 10. So first we are calling increment 1, the function increment 1, and we are passing it A. So this function increment 1, it gets its argument by value. That means a copy of the value of A is made. It is copied into another variable X. So A is a different variable, X is a different variable, and X only holds a copy of A. Okay? And then this function is called. So we are returning X plus 1. Okay, we are returning X plus 1. So basically what we are doing is we are adding 1 to X and returning that value. And we are not changing A in any way. Okay? Now there's another function increment 2, and what does it do is it gets its argument by reference. So we are passing it A has the value 10 before we call increment 2, and once we call increment 2, so increment 2, what it does is it changes X, it increments X. Okay, this is another way by which functions or subroutines can return a value. Okay, and they return a value by changing the argument which is passed to it by reference. Now in this case it changes the original variable. The original variable is A. So after calling increment 2, if you print the value of A, it would be 11 because you have incremented it. And similarly B would also be 11. Okay? So is it something good, or is it something bad? Okay, so ideally you should avoid doing that. Ideally you should avoid doing that. Why? Because it can result in bugs or errors that might be difficult for you to find. Okay, so those bugs may be obscure or hidden. It may not be, you may not be able to find those bugs very easily. Like if we have any problem in this code, you can very easily figure out that problem. If we have any problem here, so you might need to look at this function and its code. So it may be obscure, not very apparent immediately. So what is the point of, we should avoid non-const reference arguments. Okay, we can have reference arguments. At times they are essential, especially when you are dealing with arrays. So we'll talk about arrays. We haven't talked about arrays, and especially if you want to change several values, if there's a function that needs to return multiple outputs, so you cannot do it the traditional way. The C++ function, it can only return a single value. It can only return a single function. You might need to write a function that should return multiple values. So one way is either you write multiple functions that each function will return a single value and you will get all your values of interest. Or if you want to write a single function that would return all those multiple values, then you should have arguments that might need to be passed by a reference. That way you can do it. Okay? Similarly, if you have to write functions that would manipulate or change arrays or vectors, we'll talk about arrays. So then you'll need reference arguments. Arrays are almost always passed by reference. Okay. So ideally, you should always pass reference arguments as const reference arguments. Okay. You should always pass reference arguments as const reference arguments. Const reference arguments are very useful. They are more efficient, and they also like prevent the function, the callee function, from changing the data or variables in the caller function. Okay, so for example, if the main function calls increment2 function, so increment2 function will not be able to change any variable or data in the main function if this argument is passed by a const reference. Okay, so that is the benefit of const reference. Now here we have some other function. Let us look at this function here. Let us get back here. So let's see, if we say void increment2 and I declare it as a const reference, I declare it as a const reference, then I cannot do something like this. This would not be a valid thing to do. Okay, why won't it be a valid thing to do? Because now x is a const reference, so we cannot change x, and the pre-increment operator changes x, so we cannot do something like this. Okay, so we cannot increment a read-only reference or a const reference. You cannot do something like that. So const references are safe in a sense. They give direct access to this function, to the variable. This function increment2 has direct access to the variable a, but it cannot change a. But it cannot change a. There is no copying. Like when you are passing arguments by reference, you're not creating copies. So pass by reference is more efficient. Passed by reference is more efficient. Pass by value is less efficient. It is slow. Why? Because you need to create a copy of variable, so copying takes more time. Okay, so increment 1 would take more time, increment 2 would take less time, because you're giving direct access to the original variable a, you're not creating any copy. When you're passing the variable by const reference, then it is both efficient as well as safe and secure. And if you're not using const references, then you can have those obscure bugs that we talked about. Like then this function would have the ability to change the original variable in the main function, and it might be very difficult for you to find out about those changes. Okay, so if you're using a const reference, then you cannot change this variable. Okay, so let us then you can modify this function. It can also return an integer value, and you can say int. Okay, and here you can say return. Here you can say return x plus 1 without changing x. Return x plus 1 without changing x. So that would be okay, I guess. Okay. So here you see, now we are using const references, and we have also changed the code as well. So even after calling increment2, so a and b, they remain unchanged. Okay, so you cannot, with a const reference, you cannot change x, and by extension that means you cannot change a, because x is an alias for a. Okay, so let's get back to our slides. So now let us look at it once again. So you can pass values or variables by reference. That is fine. There may be occasions or situations where you would need to do that, where you need to have reference arguments. Okay, so we talked about those situations here. Ideally, you should not be using non-const references. You should only be using const references. The reason is this: like if you are using non-const references, you can have problems or bugs that might be difficult to find. So ideally, you should, if you need to pass data or variables by reference, you should be using const references. Okay. So this is another example of const reference. So we have a function f, and it is receiving it has these three integer arguments. Okay. So a is a value type, r is a reference type, and we have a const reference cr. Okay. What does the function f do? It increments all these variables. Okay. Now this statement is fine. You can increment a, you can increment r, uh, but you cannot increment cr. Why? Because cr is a const reference. Okay, so you can try this code. Similarly, so this is an error here. We have another function g. It has those three same arguments: a, b, ar, and cr. And what does this function do? This function increments a, r, acha, and then it copies cr into x, and then increments x. That is also fine. This is fine because it is not incrementing cr. It is not changing cr. It is first creating a copy of cr. It copies the value of cr into the variable x, and then it increments x. So this is fine. Acha. Now look at the main code. In the main subroutine or function, we have these three variables x, y, and z initialized to the value 0. We are calling g, and we are passing it the values x, y, and z. This is fine. Okay? So you can call this function g, and you have these three variables. You can pass these three variables to them. This is fine. How about this function call? Is this function call correct? This function call is fine. What about this function call? This function call is not correct. Why? You're passing three literals or constants, 1, 2, 3. Okay. Now you can, this variable a, it is passed by, sorry, g. We are talking about the function g. So this variable a, it is passed by value. So you can pass a constant to a value type. This is fine. But you can, when you're calling, when you're calling the function g, and the second argument is a reference type, so you cannot pass a constant value to a reference type. A reference type must be initialized with another variable. Okay, so R needs to be a variable to refer to. And what about this const int cr 3? I guess this is fine. So 3 can be passed to the const int reference cr. This is fine. Similarly, in this function call, this one is correct. You're passing a constant value to the variable or argument a. You're passing an integer variable to the reference type r, and this is a constant reference, so I guess you can pass it the value 3, which is a constant or literal. So constant references, you can use constant references. The beauty of constant references is that uh, you can pass large amounts of data very efficiently. Like you don't need to create copies of those variables or data. You can just give direct access to the original variable or data to the caller function, to the function that you've called. And by making the reference as const, you are also making your data or variables in the original function or the caller function, you're making that data safe. Okay, so the callee function, the function that you have called, that is the callee function. That function does not have access. It has only read-only access to data in the caller function, the function that makes the call. For example, main function here, it is the caller function, and f and g, these are callee functions. So when you make this function call g1 y3, so g function has access to the variable y, and this access is not read only, it is write access as well. So y, the variable y can be changed by g function. ठीक है, the variable y can be changed by g function because it is passed as reference, not as a const reference. So when you pass a variable as a const reference, like in this function call, z is passed as a const reference, then z cannot be changed. Z cannot be changed. Okay, so we have demonstrated that in the previous examples. So we've talked about references. Reference is not just limited to function calls or call by reference or call by value. Reference is a more general concept. And for example, if you have variable I with the value 7 and you create a reference R to that variable I, so what it means is that you only have a single variable uh, I in RAM which holds the value 7, and this reference R, it is just another handle to this variable R. Like there is only one variable, and that variable has been allocated these 4 bytes of memory. R is just another name for this variable. This variable is I. I is one name, R is another name, and then we are creating another reference, CR. Okay, so CR is yet another reference to this variable. So we have 3 names for this, just this one variable, I, R, and CR. You can change this variable I by using the name I and R, because R is non-const and I is also non-const. So if you want to change the value of this variable, you can use the names I and R. But CR has been declared as const, so you cannot change the value of this variable using the name CR, okay, because CR is const. So you cannot say CR is equal to 7 or CR is equal to something else. So initially I is equal to 9. When you say R is equal to 9, so this variable will be changed to 9. Okay, so this value would be changed to 9. When, let me do that. So let me get a pen. So this is when initially when this statement is executed. So this variable is created with the initial value 7. Then we create a reference R, and we say R is equal to I. So we create another name and we link that name to the variable I. Okay, so we create another name. No new space is allocated to R. No new space is allocated. R is just another name for I. Okay, so the compiler keeps track of this name, but in RAM we don't have any space for this particular variable. When we say R is equal to 9, so basically this variable I, it becomes 9. So the value of 9 is copied here. R is equal to 9 means I is equal to 9. R is just a different name for I. Then we declare another reference, but this reference is a const reference for I. Okay, so we have another reference, another name for I, but this name is const. So you cannot say CR is equal to 7, like you cannot use this reference to change this variable. Okay, why? Because this is const. Then we say I is equal to 8, so we used this name directly to change this variable. So this value would be changed and it would become 8. So when you print this cout CR, so the value of CR would be the latest value of I, whatever is stored in I. The previous have been overwritten, so you will get 8 at the output. Okay. So what is the lesson here? The lesson is that you can think of a reference as an alternative name or alias, जिसको हम उर्दू में उर्फ कहते हैं. So ये तमाम उर्फ हैं. The original variable is variable I, ठीक है, and उर्फ R, उर्फ CR, ठीक है, I, उर्फ R, उर्फ CR. So these two are aliases for I. You cannot modify an object through a const reference. You cannot modify an object. Whenever we say an object is a region of RAM. Okay, a region of RAM. Anything that is allocated some area in the random access memory. So that is an object. So through a const reference, you cannot modify an object. Through non-const references, you can modify it. Like you can modify it using R, you can modify it using I, but not through CR. This is a const reference. So you cannot make a reference refer to another object after initialization. So once you declare a reference, you have to initialize it, and once you initialize it, you cannot make it refer to another variable. So R, if it refers to I, you cannot make R refer to another variable. For example, if we have another variable J, if we have another variable J, of course that variable would be created when we say something like this: int J is equal to, say, 15. For example, if we have this statement, so then we'll have another variable J, and J will have the value 15. So if R refers to I, R is a reference which refers to I, you cannot make R refer to J later on. You cannot say anything, something like this: R is equal to J. This would result in an error. You cannot do that. Okay? This would be an error. You can try it, whether it results in an error or not, but this is how it is. Okay? So I hope you know references. I hope you know how to pass arguments by reference and what does that mean. And I also hope that you know how to pass arguments as const references and what are their implications and why you should be doing it. So how should you pass variables to a function? So you should always use call by value for very small objects. For small objects mean objects that occupy small region or area in RAM. Okay, so if that is the case, you should always use call by value, because uh, it is safe, and it is slow, but it is not that slow. But if the size of objects increases, then call by value becomes more expensive in terms of memory. You would need a lot of memory to pass variables by value. Okay, because you need to make copies of all those variables. So if you have, for example, 1000 integers, and you want to find the maximum value in those 1000 integers, so then call by value does not make any sense. You should not be using call by value. That would make things very slow. You have to create copies of 1000 variables. Okay, so you would need a lot of memory as well. So the rule is use call by value for small objects. Use call by const reference for large objects. If you have large objects, large amounts of data to process, then you should use call by const reference, not call by reference. Const reference means the callee function will not have the ability to change the original data. Okay, so you should keep that in mind. You should use call by reference only when you have to. Like you should very this is something that you shouldn't be using always. This is something that you should use very discreetly. When you really need to use call by reference, then you should use call by reference. Call by reference means like you give the callee function the ability to modify data in the caller function. Okay, so this is something that is very very serious, and you should consider it like that, and you should only use it when you have to, when there is no other choice. For example, uh, for example, if I have the GPAs of the entire class, if you are 45 students, and I have your GPAs for a given semester, and I want to sort that GPA. I want to generate a merit list who is at position merit number 1, number 2, number 3. So that means I need to sort those values, those 45 values. And if I need to sort those 45 values, then I need to give access to the callee function to move that data around. Okay, so in that case, I should be using call by reference. But if that is not the case, for example, if I want to find out the maximum value, then I don't need to give access to the write access to the callee function. Okay, so for any given situation or problem, you have to see whether you need to give access to the callee function or you don't. Okay, uh, you should always try to return a result rather than modify an object through a reference argument. Okay, so you should always be writing functions like this one, like increment 1, which returns some value. You shouldn't be writing functions like increment 2, which basically changes the value of the argument. So this is something that you shouldn't be doing. This is something that you should be doing. Okay? So you should be avoiding things like functions like these, in which you like avoiding means this is what you should do if you can do it. If you don't have any other option, then you should definitely go for the other one. But this is something that you should do. You should always try to return a value rather than modify an object through a reference argument. Okay? These are the guidelines for passing arguments. So I hope like we have covered um, almost all the aspects related to passing arguments to functions or passing inputs to functions. Okay. So now we'll talk about namespaces. We have talked about namespace, and as the name suggests, like namespaces, they deal with names or resolving potential conflicts in names. Now, how can those conflicts arise in the first place? So let us look at this example. We are not going to go into a lot of detail. Like you haven't talked about classes, okay? We have not talked about classes. Think of classes as a user defined type. Like we have these built-in types int, float and double, okay? So these are the built-in types. Now, if you want to create your own new data type, one mechanism of doing that in C++ is to create or define new classes. Okay, so you can do that. So globe is, say for example, it is a new data type. Widget is a new data type. Similarly, blob is a new data type. Widget is again a new data type. Okay. Now, in this example, consider we have two different people. One is named as Jack and the other is named as Jill, but these can be any two real persons. And they do not know about each other's existence, and they are writing codes and defining new data types or creating new data types. And somehow, by chance, Jack creates these two new data types, globe and widget, okay, and Jack puts their declarations in the header file jack.h, okay. Similarly, Jill, she also creates these two new data types. One is blob and the other is widget, and she puts these definitions in the header file jill.h. And then you come in, you import, or you're using both the libraries created by Jack and Jill in your code. This is your code, okay. So you include jack.h, you include jill.h, and this header file and this header file, it has declarations for globe, widget and blob widget classes. Now you're writing this function void my function, and you're passing it an object of type widget or a variable of type widget. Okay. Now the compiler would get confused. Why would the compiler get confused? Because you are copying declarations from both jack.h and jill.h, and both Jack and Jill have defined this new data type widget. Now the compiler wants to know which widget should I use. Okay, should I use the widget defined by Jill or should I use the widget defined by Jack? Now this is a very real situation. This can happen. We have multiple definitions of the type widget. Why? Because you are importing or using libraries created by two different people, and those two different people, by coincidence or by chance, they define the same classes or same data types. So this can happen. Now this can result in potential naming conflicts. Okay, potential naming conflicts. So your compiler is confused. It has two different definitions of the widget class. So which one should it use? In order to avoid such conflicts, the concept of namespaces was created. Okay, so namespace means if Jack is writing or defining his classes, he should create his own namespace, and then inside that namespace, Jack should basically define his classes or whatever he wants to do. And similarly, Jill should create her own namespace, and inside that namespace, she should be defining her own classes and objects and whatever she wants to do. Okay. So that can basically reduce the chances of naming conflicts like this. Okay? So the compiler will not compile multiple definitions. Such clashes can occur from multiple headers. If you are including multiple headers, these clashes can occur. One way to prevent this problem is with namespaces. So Jack creates his own namespace, namespace Jack. Inside the namespace, he can define his own classes. Similarly, Jill would create her own namespace, and inside that her namespace, she can define her own classes. Then you can include both the header files, and you can specify which particular widget do you want to use, Jack's widget or Jill's widget. Okay, so this is about namespaces. So we have been in our code so far, we have been using the standard std namespace, and we mentioned it that if you don't use the using statement using namespace std, so then you have to specify the name of cout and cin like std, and then the scope resolution operator. Okay, scope resolution operator, and then, sorry, this the scope resolution operator is something like this, and then you have to say cout. So that is the full name of cout. Cout is defined inside the namespace std. So namespace std, it has the cout object, the cin object, and all these objects. So whenever you say cout something, basically it is std and then the scope resolution operator double colon, then cout. Okay, so that is the full name, full qualified name of cout. So let me draw it here. Say this is okay. So if you don't want to like write the full name of cout, so you can say in the very beginning, you can say using namespace std, and then wherever there is cout, so std, and then the scope resolution operator, that would be automatically appended by the compiler. Okay, so this is the idea of namespaces. Okay, so if multiple people are creating or writing code, they can create functions, or they can use names which might be used by other people as well, and you as a programmer might include code from both different from different people, and those different codes from different people can have the same names. So then your compiler will flag a multiple definition kind of error. So in order to avoid those clashes, C++ has come up with this idea of namespaces. Okay? So there can be a question like, what happens if two people with the same name, they start writing code, and they create they end up creating uh, classes or functions like these. ठीक है, एक जैक जो है वो अमेरिका में है, दूसरा जैक फॉर एग्जांपल बर्तानिया में, and both these jacks, they start writing code, and they end up with similar names for their classes, and you are using both jack.h and jack from us.h and jack from britain.h. You include those files, and then you'll end up with the same problem. Yes, that is also a possibility. So then some languages like they they put in place some rules कि namespaces के नाम फिर क्या होने चाहिए. So for example, Java had a very had a very useful way of doing it. So you are aware of domain names. Domain names ये जो websites के नाम होते हैं. For example, www.google.com. ठीक है? So this is domain name, www.google.com. So this is a domain name. Now domain names are unique. Domain names को register करने के लिए there are standard bodies. So they make sure कि ये जो domain names लोगों को मिलते हैं, they are unique, they are not the same. ठीक है? So Java ने ये रूल बनाया कि अगर आप अपनी नेम स्पेस क्रिएट करते हैं ना, तो उस नेम स्पेस को you name it just like your domain name in reverse. So अगर Google कोई library create कर रहा है, so Google should put all its classes in the namespace com.google. ठीक है, com.google. That should be the namespace for Google. So if Apple is creating its classes or creating its library, so it should create the namespace com.apple. ठीक है, I don't know whether namespace में हमें we can use dot or not. I guess we cannot, I'm not sure, but Java allowed that. So ये सिर्फ simple एक side question था कि अगर आपके पास नेम स्पेसेस को यूनिक करना है तो नेम स्पेसेस को कैसे यूनिक करें? सो नेम स्पेसेस को यूनिक करने का तरीका यही है कि ऐसे नाम जो ऑलरेडी यूनिक हों, लाइक समबडी हैज़ टेकन द एफर्ट, has done the effort of ensuring that those names are unique, so you should use those names. But ये questions जो हैं ये हमेशा मतलब किसी न किसी फॉर्म में रहेंगे, so you have to take some care while you're writing or creating your libraries, so you have to ensure that your names are unique from potentially other people creating similar libraries. ठीक है? So what is a namespace? A namespace is a named scope. So what is a scope? So we talked about scope in our previous lecture. Scope is a region of your program where basically it is any region of your program. ठीक है? The scope is related, किस चीज़ से इसका ताल्लुक है? With variables के कोई भी variable किस region में visible है और किस region में visible नहीं है. So a scope is basically a namespace is a named scope. So you give a certain region of your code a name. ठीक है, और उसके अंदर फिर आप मजीद नेम्स डिफाइन करते हैं. यू यूज़ द स्कोप रेजोल्यूशन ऑपरेटर, ठीक है, टू स्पेसिफाई किस नेम स्पेस को आप यूज़ कर रहे हैं और उसमें से किस ऑब्जेक्ट को आप रेफर कर रहे हैं. ठीक है, सो फॉर एग्जांपल वी हैव बीन यूजिंग द स्टैंडर्ड नेम स्पेस एसटीडी नेम स्पेस, और उसमें बहुत सारे ऑब्जेक्ट्स हम उनको यूज़ करते आ रहे हैं. सो वी हैव बीन यूजिंग सी आउट ऑब्जेक्ट, वी हैव बीन यूजिंग सी इन द कंसोल इन ऑब्जेक्ट. अच्छा, वी हैव बीन यूजिंग द एंड लाइन कांस्टेंट. ठीक है, सो यू कैन स्पेसिफाई कि ये जो तमाम कांस्टेंट्स हैं या ऑब्जेक्ट्स हैं, दे आर इन द एसटीडी नेम स्पेस, दे आर इन द स्टैंडर्ड नेम स्पेस. ठीक है, सो दिस इज द सिंटैक्स फॉर एक्सेसिंग these or using these names. सिंटेक्स में क्या है? फर्स्ट द नेम ऑफ द नेम स्पेस एंड देन द स्कोप रेजोल्यूशन ऑपरेटर. ठीक है, स्कोप रेजोल्यूशन ऑपरेटर. सो नेम स्पेस इज बेसिकली अ नेम्ड स्कोप. किसी स्कोप को आप नाम दें. स्कोप क्या चीज़ है? रीजन ऑफ अ प्रोग्राम, रीजन ऑफ अ प्रोग्राम. ठीक है, रीजन ऑफ अ प्रोग्राम. सो दिस इज बेसिकली कॉल्ड स्कोप. अच्छा, ओके, सो यू आर अवेयर ऑफ इट. आई होप यू आर अवेयर ऑफ इट. दैट्स व्हाई वी यूज, या तो आपने यूं फुल नाम लिखना है. सी आउट क्या चीज़ है? सी आउट नेम स्पेस एस टी डी का एक ऑब्जेक्ट है. या तो ये काम करना है, और या you have to use the using syntax. ठीक है, you have to use the using declaration. ठीक है, so either you do it this way, but this is tedious. बार बार आपको ये काम करना पड़ेगा. जब भी सी आउट को आप रेफर करेंगे, you have to write its full name std and then the scope resolution operator सी आउट. So this is tedious. What you can do is you can say using std. अगर आपने सिंपल एक पर्टिकुलर ऑब्जेक्ट को यूज़ करना है, यूजिंग std then the scope resolution operator सी आउट, so this is also fine. But अगर आप कहते हैं कि using namespace std, so then for all the objects defined in the standard namespace आपको ये वाला syntax यूज़ नहीं करना पड़ेगा. ठीक है, so either you do it for just a single object, say सी आउट. ठीक है, इसका मतलब क्या है? यूजिंग std and then the scope resolution operator सी आउट. What does it mean? It means when I say सी आउट, it means std and then the double colon सी आउट. That is what it means. Using का मतलब ये है. So जब आप अपने प्रोग्राम में you write this statement, your compiler knows कि सी आउट here means std double colon सी आउट. अच्छा, when you say cin, so the compiler will give you an error कि ये cin क्या चीज़ है. ठीक है, because आपने cin के लिए you didn't say using std and then the scope resolution operator cin. You didn't say that for cin. So आसान तरीका ये है कि you just say using namespace std कि I'm using currently I'm using the standard namespace. ठीक है, what will it do? It will make all the names from the namespace standard available to you. So then you don't need to say कि ये एस टी डी डबल कॉलन सी आउट या एस टी डी डबल कॉलन सी इन या एस टी डी डबल कॉलन एंड लाइन. यू डोंट नीड टू से इट फॉर एनी ऑफ दीज. ठीक है, इन तमाम नामों को आप यूज़ कर सकते हैं विदाउट स्पेसिफाइंग द नेम स्पेस. अच्छा, बट यू शुड बी केयरफुल. व्हाट इफ़ यू आर यूजिंग मल्टीपल नेम स्पेसेस? फिर क्या ये तरीक़ेकार ठीक होगा? आप एक से ज़्यादा नेम स्पेसेस एक प्रोग्राम में यूज़ कर रहे हैं. ठीक है, तो देन दिस मे नॉट बी द ऑप्टिमल वे ऑफ डूइंग थिंग्स. ठीक है, दिस मे नॉट बी द ऑप्टिमल वे ऑफ डूइंग थिंग्स. अच्छा, उसमें फिर क्या करना है? So that I'm not sure whether we'll be able to discuss it in this course or not, because mostly the standard namespace is good enough for us. All the standard library के जितने भी functions हैं, so they are available to us through the standard namespace. So we may not need to go into those details, but this is something that you should always consider कि अगर आपके पास there are multiple namespaces that you're using, so then this statement using namespace std, is it the best thing to do or not? So you should always keep that in mind. ठीक है? It may not be the best thing to do. The short answer is it may not be the best way of doing things, because then you're using multiple namespaces. So you have to be sure कि कौन सा object, the compiler needs to know precisely कि कौन सा object किस namespace का है. यहाँ तो चूंकि हम namespace std के तमाम objects और constants और variables वगैरह को यूज़ कर रहे हैं, तो यहाँ एक ही मरतबा हम कह देते हैं कि यूजिंग नेम स्पेस स्टैंडर्ड, तो उसके बाद फिर हम उस नेम स्पेस के ऑब्जेक्ट्स वगैरह को यूज़ करते हैं विदाउट राइटिंग देयर फुल नेम्स लाइक दिस. ठीक है, विदाउट राइटिंग देयर फुल नेम्स लाइक दिस. बट इफ़ यू आर यूजिंग मल्टीपल नेम स्पेसेस देन दिस मे नॉट बी द ऑप्टिमल अप्रोच. ठीक है, so this is it for this lecture. In this lecture we talked about namespaces. ये अभी हमने इसके ऊपर बात की. We have already talked about it but not in this detail. So the problem comes here जब आप multiple लोगों की libraries को use कर रहे हैं and those people happen to use or define classes or objects or names or functions with the same name. ठीक है, तो उस केस में अगर आप ये जो सिमिलर नेम के जो ऑब्जेक्ट्स या फंक्शंस हैं उनको अगर आप यूज़ करना चाहते हैं, so then your compiler might get confused because of multiple definitions. ठीक है, so उनको कैसे avoid किया जाएगा? That you would avoid by creating or defining main namespaces. And how would you define namespaces? Just like this. So this is namespace Jack, and this is say namespace. Similarly, you will have a namespace Jill. So now this particular class belongs to the namespace by Jack, and you will have another widget class that would belong to the namespace created by Jill. So then जब आपका प्रोग्राम आपका जब कोड इस पर्टिकुलर क्लास को यूज़ कर रहा होगा, so it would specify कि I want to use the widget class by Jack or I want to use the widget class by Jill. So that would reduce the naming confusion. ठीक है, but इसमें हमने mention किया कि what if the namespaces are are the same. namespaces का नाम अगर सेम हो तो फिर क्या करें? तो उनको यूनिक रखने का एक तरीका हमने बताया जो कि जावा में यूज़ होता है. So you should keep that in mind. I won't be asking you to create your own namespaces, but you should have a very clear idea of what namespaces are. Acha. Then we talked about, before that we talked about passing arguments by reference and by const reference. So in general, these are the guidelines for passing arguments to function. So you should understand these guidelines and you should follow these guidelines as much as possible. ठीक है? And you should know the implications of each. So हमने references को discuss किया again, and we talked about const references and what is different about const references and normal references. ठीक है? So we talked about this. I hope these things are clear to you. If you have any questions, you can always ask any questions. In the next lecture, we'll talk about functions one more time, and that would be in a special context where right now हम क्या करते हैं? We write functions and we call those functions from the main function. तो हमारा main function जो है ना वो इन functions को call करता है. ठीक है? So this is say call to the function g, this is another call to the function g, this is yet another call to the function g. So there can be situations where a function can call itself, like g can call itself. If that is the case, इसको हम कहते हैं recursion. So in the next lecture we'll talk about recursion. Recursion is when a function calls itself. A recursion is when a function calls itself. So what happens then? So recursion is also an important way of solving problems using computers. And some problems, they are very easy to solve using recursion than any other technique. ठीक है? So इसको हम देखेंगे next lecture में. Until then, Allah Hafiz.